Welcome to today's lecture and welcome to Introduction to Manufacturing. Today we're going to talk about manufacturing processes. This is the introductory lesson for our C4M curriculum. We're going to pretty much keep it light today. We're going to cover just the basic concepts of the processes that go into manufacturing. There are a lot of them out there. Today pretty much what we're going to talk about is some of the very introductory, elementary level processes of manufacturing. We're going to try to keep it light, make it fun, cover everything you need to pass your exam at the end of the lesson. Here's some of the basic manufacturing terms. Here there are very few of them. Turning, which is a basic machining operation where a single tool moves the material from a rotating workpiece. Drilling is a machining operation that removes metal to form a single hole. Tapping is a process of cutting internal threads into a pre-existing hole using a tool called a tap. Reaming. Reaming is the process of using a rotating tool called a reamer, hence the name reaming, to enlarge an existing hole. You already have an existing hole that was drilled by a drilling operation, therefore you're reaming it, making it a little bit larger. Boring. Not quite as boring as this class, but boring. Boring is an operation used to cut into an internal surface of a workpiece to form different features, such as stair steps or even maybe contours into a workpiece. Milling. Milling is a process of moving a rotating tool with multiple cutting edges to generate a plane or straight surface. Remember, this time you're talking about a tool doing the rotating, milling, whereas in turning is more like of a lathe. The material itself is chucked into a workpiece and it's rotating while the tool itself is stationary. So milling is a little bit different than turning, but chances are they kind of can in some cases do a very similar job. Milling typically will be a straight plane or flat surface. Continuing on to manufacturing terms, some things we want to talk about. Those were processes we talked about in the past. Those can either be manual control, where an operator adjusts the feeds, speeds, changes the tools, and monitor progress, where an operator is right there doing the work. Or you can use a computer to do it, and there's different ways of using computer programs. A lot of them are called CNC machines, which we'll talk about down in computerized numerical control. But numerical control uses a computer program to adjust the feeds, the speeds, even changes the tools. Numerical control machines have become the standard for speed and quality in manufacturing. You have a direct numerical control, which uses a single central computer to control operations of multiple machines. You have several machines working out throughout the area, maybe even at a remote location, and this direct numerical control is feeding, controlling, adjusting, changing out tools. And then, of course, computerized numerical control uses a dedicated computer to control a single machine. We've all heard of CNC machines, seen them on TV, watched them on YouTube. A CNC machine, it has a computer built into the machine itself. You program it and it runs out through its process to finish with a final assembly. And then you have assembly line. Assembly line is a process in which machines, tools, and workers or work is arranged in a manner to which allow the product to be assembled. It starts one thing, pieces are added as it goes along the assembly line to the end till it rolls off of a final full assembly. Heat treating. Heat treating is the actual of taking a piece of metal or metal component, heating it to a certain temperature, and then cooling it with air, water, or oil real quick to release the stress. It actually changes the physical properties. So heat treating is when you want to change the property of a certain type of metal for the manufacturing process. You can utilize heat treating to make that happen. Fabrication. The term fabrication is a process where assemblies are constructed using raw materials or other subassemblies. Fabrication can involve forming, machining, welding, or a final assembly. It's kind of the same as an assembly line, but say there at your computer, you're looking at your mouse that you have there, and somebody actually had to put that together. They were made of several different sub-assemblies, but somebody's fabricating those sub-assemblies, or actually fabricating that mouse by actually putting it together. Not necessarily through an assembly line, but sitting in one little stage doing it. Continuing on with some more terms, extruding. Extruding, back to rolling and drilling. Extruding is a process of squeezing a metal using a die and a mechanical or hydraulic press. Pretty much you have a die of what you want this item to look like, and you're using force to shove the metal through it, and at the end only what you're wanting left is used, kind of like a cookie cutter to some extent. Rolling is a process of straightening a material into uniform thickness or profiles. Rolling is performed by feeding the material through a series of rollers that are under pressure. And if you continue to feed them back and forth, back and forth, back and forth, the rolling motion will either straighten or actually make it thinner to a certain thickness that you want. Okay, now we're going to get a little more detailed stuff. We're going to talk about traditional manufacturing, or the push manufacturing, as some people like to call it. It was based on producing goods to satisfy a perceived need. Production times were long. Raw materials were ordered based on projections. Well, we know we ordered, we made 500 of them this time last year. We need to go ahead and order 500 more. Finished goods went in inventory until orders were received. Unsold inventory was carried as an asset, costing the company money to produce and to store. So instead of going right to the end user, it was stored waiting until the end user called. Just-in-time manufacturing, JIT, or even the pull manufacturing, as some people like to call it, has proven to be a little more effective than the push manufacturing. Just-in-time means producing the necessary product in the needed quantities at the right time. Production runs are scheduled based on orders, actual customer orders. Orders trigger the ordering of raw materials that can go directly to the production line. Finished goods can be shipped directly to the customer. There's no unsold products, so therefore you don't have all this inventory standing by. Production begins with a customer order. Each is finished. The product is made to order using a pull. The use of pull leads to higher customer satisfaction. And lastly, inventory costs are significantly reduced. But you need to let your customers know that you do use just-in-time manufacturing, so they do understand when they place an order that it may take a certain amount of time to get. Good example of this is your local pizza place. You call in an order, you place it online, you use your little pizza app on your phone. It places the order. At that time, they take raw material, make your pizza as you specified, and they usually tell you, well, it's going to be 20 minutes, it's going to be 15 minutes, 35 minutes. Around my house, an hour at times. So they're getting the pizza out to you, but you got what you wanted at the same time. Isn't that the same definition of just-in-time manufacturing? Sure it is. And there's not pizza sitting under the heat lamp anywhere waiting for somebody to walk in and just buy them. Modern technology shortens that lag time between the order and the delivery. Okay, we just talked about just-in-time from the order to the time that it's actually delivered. Well, using modern technology, we talked about like the pizza guys. You pick up the phone, you use your phone app, you're on the internet, at your favorite website, your favorite pizza website, and you place your order. All that uses modern technology. But not only what it does, it also helps track the order systems so that when the manufacturing process is working, they know they use so many raw materials, so much raw materials. Well, I know I used 300 I-beams, 400 bolts in each process. I know I made 500 of them. I can place an order more regularly. And they can do that by using a few different things, such as radio frequency identification. It's a wireless non-contact radio tags, which is read by sensors, and a conveyor system. So as it's running through a system, the computer system picks it up, registers it, and then files a list of things that need to be ordered or not ordered. Automated order picking systems. That helps a lot by removing the labor. Manpower is very costly, and when you're talking about types of manufacturing, it's very, very costly, very cost part of the process. And by using automated order picking systems, you can reduce some of your labor costs, and it can also be operated with paperless pick sheets. Therefore, you can use a laptop, iPhone, some sort of wireless device to help you or help the automated order picking system to do their job. Well, that completes today's lecture on manufacturing terms. I hope you find it as interesting as we do. The manufacturing process is very interesting, and I want you to leave today understanding that the manufacturing is a very broad term. It's not about one thing. Manufacturing of a car versus manufacturing of like your computer keyboard sitting right there, or even manufacturing your phone. Each one of them are different, but the concepts, overall concepts that we talked about here today are very basic. They're very generic, and they can fit each one of them. So continue on to our next one. Our next one is going to talk about quality, quality manufacturing. So sit tight and get ready to look for the next one, and good luck.